it might not pick up my voice. Okay, so at this time we are starting notes. So if everyone could please put away your devices, cell phones, work from our classes. I'm going to turn down the brightness just a bit. Seems. Is that good? It will seem like really bright for. Okay, so one of the most important properties of the majority of functions that model real-world behavior is that they are continuous. What that means is that there is no break in the graph. So the graph continues on. There are no holes in it. There are no asymptotes. Nothing like that. Now, some functions have discontinuities, and on the back of this page, if you look, there are 4 different types of discontinuities. I'd like you guys, just from their names, to guess which ones each of those are. Why is this like that? There we go. Okay, so A, B, C, and D, please put them in the blanks here. Because it is multiple choice, you will only have one chance to answer, and I will give you a point for each one you get correct. Go ahead. B has 2 graphs, because there are 2 types of that discontinuity. Yeah, whenever you have it, yeah, just write it down on your board, but keep in mind you only have one chance to answer, so make sure all your teammates agree. Yes, all correct. One correct. All correct. Two correct. All right, let's go over these. So the answers were A, B, D, C. Can I turn the page? Yes. All right, so, gosh, that picture is so clear. So A is continuous. B is removable. And removable can look like this, or it can look like this with the point appearing somewhere else. C is infinite. And D is jump. It's not going to be super necessary to memorize the different types of discontinuities, but every once in a while I'm going to say, hey, this function has an infinite discontinuity, or hey, this function has a removable discontinuity, and I want you guys to be able to visualize what I'm talking about. Okay, so it's not going to appear like on a test, but it might appear like in the instructions for a problem on the test. Okay, I don't remember why I put this gap here. That's okay. There are 3 graphs. I'm going to label this one A, this one B, and the one on the back C. They're asking, and each graph gives you the actual equation that goes with the graph. They want to know which of the following graphs are discontinuous at x equals 2. So for A, B, and C, please say continuous or tell me the type of discontinuity you observe. Yes. So that's what we just were doing. There was a removable discontinuity, an infinite discontinuity, a jump, a break in the graph. So if you look at A, you see how there's no break in that graph? That graph is continuous. If it's discontinuous, that means there is a break in the graph, and there are different types of breaks that might appear. A discontinuity. So it is not continuous. Discontinuous. So for A, B, and C, please tell me either it's continuous or tell me the type of discontinuity that you see. Go ahead.
Available next week.
Yeah. Always. I'm going to post my hours either Friday or Monday. And then, as always, if you can't make those times, send me an email. I'll try to accommodate you, or we might just meet the following week. That's what a lot of people do. Do you have block G off?
Yeah.
Almost any day block. Okay. Every once in a while, I have a meeting during block G. Usually.
Since I leave for 10 minutes, I don't.
I got you. I understand. Yeah. Yeah. You can also. I always encourage people to make study groups, and studying is always more fun for things.
Mm-hmm.
Yeah. Yeah. So answer A, continuous. B, removable. Whatever you say. So you guys are answering A, B, and C. Tell me, say either continuous or give me the type of discontinuity you observe. And there are only 4 possibilities for each of these, so you only have 1 chance to answer. And I will give you 1 point for each one you get correct. Oh, yes. Oh.
This is got me.
Oh my God.
So C is not.
You're going to answer A, B, and C. Tell me for A, B, and C, you're either going to say continuous or you're going to say removable, jump, infinite. Yes. 2 out of 3. That makes sense. Don't share answers. Oh, I'll go. That's really sweet, man. I'm crying. So I need to know the type for C. least on the second try. Okay, so, ladies, this is an infinite discontinuity. This is continuous. And this is a removable discontinuity. Any questions?
Yeah, I don't.
Can you see the hole?
Yes.
If there's a hole, it's removable. Yeah. Now, another way you could determine, like, let's say that you couldn't tell there was a hole there. If you look at the equation, if you plug in 2, what do you get in the denominator? 0. So you know it's discontinuous at 2 because you can't have a 0 in the denominator. Does that make sense? Okay. So either from the graph or from the equation, you can figure out it's discontinuous there. Removable discontinuities are the hardest to find graphically because on your calculator, it won't give you a circle. It'll just give you a tiny break. So the equation, if you plug 2 into the denominator, you get a 0 in the bottom, and you can't have a 0. Well, it was asking specifically for 2. Yeah, the question was asking for at x equals 2. Any questions on discontinuities? All right.
I was going to ask you to, like, plug in something.
When you say always, there's like a million different types of questions you could get. This problem did. I mean, there are a bunch of other types of problems. I could just give you the equation and say, is this function continuous? Well, you could graph it on your calculator, or you could just figure it out algebraically. Yeah. Or I could give you different criteria for an equation and say, do something with this, figure out what the equation is, and then tell me is it continuous. So there's lots of different. When you say always, I kind of go, well, not always. I can't even think of all the different types of problems. Yeah.
So could you just give us like this?
What's that?
You could just give us this part.
Yeah, you are able to figure out if it's continuous just from the equation. Any other questions? Okay, are you guys all familiar with increasing and decreasing? Have you heard those terms before? No. You've never heard the term increasing or decreasing?
Yeah. That's going up or down.
So if I graphed something and I said, is this increasing or decreasing? Could you figure that out?
Decreasing? Wait. Increasing and then decreasing is this.
Anyone who took Algebra 1, I think, should. It's increasing. Why? How do you know it's increasing?
It's going positive.
It's going up. So from left to right, if it's going up, it's increasing. From left to right, if it's going down, it's decreasing. Everyone has learned that, I'm sure. Okay. So most equations that are not perfectly straight lines, they have a mix of increasing and decreasing. Sometimes they're increasing, then they're decreasing, then they're increasing and decreasing, etc. For this next problem, you need to graph it on your calculator and then give me the interval notation for when it is decreasing and when it is increasing. I will give you 1 point for each. I feel like you're playing. Like, you know what increasing and decreasing is. I mean, you're in this class. Yeah.
So if you look at where
Right here?
yeah, like when it starts going up and when it starts going down.
That's -2,
So that's
4. X is -2, y.
How did you do that?
And then
Because it's up here. there's a little circle.
So give me decreasing and increasing.
Oh, wouldn't it just be negative? Oh, is it this? Oh, because I mean, is it or does it? This is decreasing. So oh. How do we determine that? And then negative 2. Yeah. Okay, so it is that. Okay. Is it included or not?
Alright, that's that was great
So
job.
like she asked for increasing and decreasing and this
I'm gonna give you guys one more minute. Yes. The only thing is brackets on the negative.
oh, that was my question.
And that is
So it includes the negative.
yeah, negative 2. It is both increasing and decreasing.
So you know how it brackets negative?
I'm asking for the interval notation. Where is it decreasing and okay. Oh my god. Oh wait, you're team 2.
Is it bracket on the 2?
On both.
Yes, bracket on both because it's both increasing and decreasing at negative 2.
Do you look like?
Alright, ladies. Let's talk about this. So did everyone at least graph it? Now you can also graph it by hand. You know that x squared is a parabola, right? If you're adding 2, then moves 2 over. Okay? So, ladies, we're looking at where this is increasing and decreasing. From left to right, it's decreasing at the beginning. And then at negative 2, it starts increasing. So, right. So it's decreasing from negative infinity to negative 2. Exactly. And then negative 2 to infinity, it's increasing. Yes. Good question. So with parabolas, at the minimum or maximum, it is going to be both increasing and decreasing. With absolute value, at the point, it is neither increasing nor decreasing. So parabolas with both, absolute value is neither, or anything with a point. Yeah, so at this one point, it is neither increasing nor decreasing. So if it looked like this, it would be parentheses. Does that make sense, ladies? Okay. Any other questions? We'll write down the answer here. All right, ladies. This next problem I would consider to be a challenge problem. I would eventually like all of you to be able to solve problems like this, but today, if you struggle with this one, I'm okay with it. I just want to stretch you a little bit to see if you guys can figure this one out. Give me where this one is decreasing and increasing. Yes. Play with it. Like it's one of those things you just have to get used to the window. You guys are all gonna get real familiar with these calculators. You can also explore Zoom, although I don't usually use Zoom. There are students who do. If that's easier for you. We will go over this one. I'll give you guys 2 more minutes. I'll give you 1 point for each of these. them are unions. One more minute. Anybody else have all right. Okay, so did everyone get a graph that looks like this? If you did not get them, you probably did not put your denominator inside parentheses. Oh. That's the only thing that went wrong. Okay, so the reason this problem is tricky is because it's up here and then all of a sudden it's down here and then all of a sudden it's up here again. So it's sometimes a little confusing to figure out, okay, is it going up, is it going down, what's going on? From here to here, the graph is increasing. But there is a discontinuity here. -1. Then from here, it's decreasing. And then there's a discontinuity here at 1. And it's decreasing again. I will give a bonus point if someone can tell me how to figure out that this is -1 algebraic. Let's say you can figure it out while you calculate. Just tell me how you figure it out algebraic. Anybody else? What was it? Yes, if you look at the denominator, x squared minus 1 equals 0, add 1 to both sides, x equals positive -1. Sorry, this is done. Okay, so you know that the asymptotes are -1 and 1. So even if you can't tell on your calculator, you can tell algebraic. So this is decreasing from 0 to 1 and from 1 to infinity. You see that? So from 0 to 1 is not including 1, and then from 1 to infinity. It is increasing from negative infinity to -1 and from -1 to 0. No, no. That was what she just figured out. Because the equation.
Yeah, and I didn't realize that. Yeah, we didn't realize that it could do that.
Yeah.
So,
That's what you would want to do.
okay.
You can also use the graph, but it's imprecise, especially if it's not a whole number. Like if it's a fraction or decimal. Yeah, I recommend you do that algebra. If you need an exact number, do it algebraically. Alright, so once again, it's decreasing from 0 to 1 and from 1 to infinity. It's increasing from negative infinity to -1 and from -1 to 0. Alright. Any questions before we leave 1.2 part A? Alright. 1.2 part 2. Okay, so a few terms. Bounded below, bounded above, and bounded. These are the technical definitions. I'm going to draw what they mean, and I think it'll make a lot more sense if you see some pictures. Yes? Where is it? Yeah, so it's not equal to -1 because there's a discontinuity. Okay, so if you have a graph that looks like this, can you see that the graph is continuing up forever, but it does not continue down forever? That means it is bounded below. If you have a graph that continues down forever, but it does not continue up forever, it is bounded above. Make sense? And if you have a graph that does not continue in either direction, this is called bounded. Any questions? Alright, I'm going to label this as, actually there's only 2 of them. Please graph these on your calculators and tell me if they are bounded above, bounded below, or bounded. Or none. Because there's only a few possible answers, you only have one chance to answer, so make sure your teammates agree with you. Well, it's either bounded above, bounded below, bounded, or none. You're doing both of them. Yep. You're all right. Okay, that's correct. Did I give you guys your bonus point? Yes? Yes. You got it, team 4? All right, so everyone got it? Would anyone like me to go over it? Okay, so this is bounded below. And this is bounded. All right, now, you guys have all learned about maximums and minimums. Yes, you have. Like, I've talked to the teachers who taught you algebra, so I know it was covered. Okay, maximum minimums. This is the minimum. This is the maximum. Yeah, now you remember? Okay. So I'm going to show you guys how to find maximum and minimums on your calculator. So when you're in a situation when you can't, or for whatever reason don't want to solve for it algebraically, this is what you would do. Someone give me an equation that has a maximum. Wow. Any equation that has a maximum. I'll give a bonus point. If someone can give me an equation that has a maximum, raise your hand. Give me an equation that has a maximum. Any equation that has a hill. I'm looking for hands. Oh, yes. Negative. X minus 2 parentheses squared has a minimum. We could use that. 3x squared plus 5 has a minimum. Anyone have
Minus 5. X squared has a minus.
Wait, no, team 4 you already had it. Anyone else? Like, all of these are good and we could use them to find a minimum. I just was asking if anyone could give me an equation that has a maximum. That works. Yeah. It has to be negative. So this equation is going to look like this. please graph this on your calculator. And I'll start writing out a few steps. So these are the steps you use after you have graphed it. First thing you need to do is graph it. But after you've graphed it, everyone ready? Yeah. Yes. Everyone ready? I'm going to graph it on my calculator. Give me a sec. And I'm going to make my window negative 10 to 10. You don't need to, but that's what I'm doing. So it looks like that. Okay, has everyone written the first step? So, you'll see. Depending on if you're finding a maximum or a minimum. You're going to hit 3 or 4. Okay, so, first thing you're going to do, you're going to hit second. Then trace. And then on the list, if you're looking for a minimum, you're going to hit 3. If you're looking for a maximum, you're going to hit 4. What are we looking for here? A maximum, so I'm going to hit 4. Now pause. Pause. The next step. You're going to move the cursor to the left of your max or min and hit enter. That says enter. So using these arrows, I'm going to go a little bit to the left of my, I can see where my maximum is, right? I'm going to go a little bit to the left. And I'm going to hit enter. Then pause. It's the left bound.
So I have, wait.
You guys, you just move the cursor and hit enter. You can move it like one space, and that's sufficient. Because the cursor starts at the minimum, or the maximum in this case. It doesn't always do that. Then you're going to move to the right of the max or the min. And you're going to hit enter again. Okay, someone says they're so confused. What's up?
Oh, no,
Okay. Okay, so I'm going to move the cursor to the right. And hit enter. Okay, so this is what we've done so far. I'm going to hit clear, and I'm going to start over. Okay? Okay. You'll see. It'll all make sense once you have all the steps. This is how you measure the highest point between your left and right bound. Don't hit clear. But some people are lost. I'm going to start over and do it all again. Because the last step's really easy. May I? Okay. So, once you've graphed it, you're going to hit second, trace, max or min, left bound, enter, right bound, enter. Doesn't matter as long as your cursor ends up to the left of the max or min, and as long as your cursor ends up to the right. Make sure it's kind of close, but just needs to be to the left or to the right. Then it's going to ask you, guess, and you're going to type enter. So make sure it says guess down here. Hit enter again. Okay, if it gives you E like that, that means 0. Yeah. Sometimes it gives you this scientific notation. That means 0. So this is 0, 0, positive 3. So once again, if you get something like this with an E next to it, that means 0. No. Everyone will get different numbers if you did not get a 0 here. If you did not get a 0 here, you're going to get some scientific notation that's very, very small. Okay. Now, it's important that you understand this procedure will find the highest or lowest point between the left and right bounds. Okay? It's important that you know that, because if you do something that messes up, for example, if you accidentally hit minimum instead of maximum, it would give you the lowest point between the left and right bounds, which is probably one of the places where your left and right bounds were. Okay? Yes? I don't know why. At the bottom of the screen. The maximum? So the maximum of this one would be 0, 3. That's the ordered pair. So you hit, are you following all the steps?
No.
You have a TI 84 plus? You're doing something wrong then. Either that or your calculator. And then it will say yes. Yep. Okay, we are now at the place where the last class left off, so I'm going to have us stop. We will talk about how to find zeros on the calculator next time we meet. Your homework is up through 1.2a. Let's finish all the homework through 1.2a. Okay, before I let you guys start working on that, I need everyone to please make one pile of all your math notebooks in the center of your table. Once you have your piles, please bring your piles and put them on top of this box over here. I just realized I can stop notes now.